Mars rovers, RS-1, RS-2, Gaia Rover, as well as underwater robot. Robotics is a direct successor of Iris project and was founded in 2015 with pretty the same aim. In Robotics, we are engaged in construction of Mars rovers, as well as construction of underwater robot. What is more, member of Robotics, Michał Kazaniecki, took part in the first Polish Mars analog mission EXO-17. Now let's move on to the Mars rover design and construction process. I'm going to show how it works in Robotics, and since each project is a little bit different, I'm going to show it mainly on the example of RS-3 rover. At the very beginning, during initiation phase, mainly on the basis of competition requirements, the team is divided into smaller groups dealing with specific subsystems. And then during the next step, the next stage, mainly on the basis of competition rules, we formulate exact requirements for the subsystems. And then when we exactly know what are requirements for these subsystems, we can proceed to the design phase, which in comparison with the other phases takes most time and requires considerable skill. When the design phase is over, we can then order the parts of the rover and then just assemble it. When this is over, there is time for the most critical phase of testing our rover. We can then verify if everything works as it should and if all project assumptions are met. If not, there is still time for make some changes, after which the rover should be ready to participate in competition. And returning to the design phase, each rover subsystem is assigned to one of the following groups: mechanics, communication, software, and electronics. And mechanics group is further divided into mobile platform and specialized equipment. Specialized equipment systems form the basic construction of the rover, allowing it to move, while specialized equipment systems take part in individual competition tasks such as soil sampling or manipulating panel switches. Mobile platform systems include one of the following in order from the ground. This is wheels, transmission, suspension, and the frame to which many other elements are attached. On the other hand, the specialized equipment systems include, for example, manipulator, then grippers and shovels, or drill specially designed for drilling and sampling soil. Next to the mechanics group are a communication, software, and electronics group, which because of its similarity we call just ElcomSoft. Members of ElcomSoft provide not only the communication between rover and the base ground station, but also provide data sensor readings and drill control, manipulator control, as well as whole rover control, and they implement some autonomous navigation systems. And here is the distribution of tasks in our projects shown in one piece. At some point, we decided that we would have 2 project leaders instead of 1. And as a result, one project leader can focus on organizational issues such as traveling to the competition place, shipping the rover, while the second leader supervises the design and construction of the rover. Each sub-project is controlled by the mechanics or ElcomSoft supervisors, but can be supervised directly by the project leader as well. Every week or every 2 weeks, the whole team gathers at the meeting, during which sub-projects' progress reports are presented, which is kind of motivation to make a regular progress in work. And secondly, this is the great opportunity to exchange requirements between sub-projects. For example, the real designer needs to indicate the frame designer where he wants to attach the drill to the frame, and vice versa. A frame designer indicates the drill designer where he can attach the drill to the frame. For another example, Rover electronics designer needs to know how many electric motors are planned to be mounted on the manipulator and which kind of electric motors. In addition to the regular meetings, we try to communicate via internet using Slack, for example, and we also try to upload our project files on Google Drive or Dropbox, which makes it really easy to work remotely. To meet the deadlines, each sub-project is using a Gantt chart. Since 2009, members of Student Space Association have constructed at least 5 rovers, and now SCA Robotics members are working on the brand new rover that we called Sirius. The Skarabeusz rover was constructed in 2009 and was a prototype of a robot that could navigate in the difficult conditions on the Red Planet and explore it. It was the first Polish rover to take part in any international rover challenge. And if, in spite of problems with traveling to the competition area when due to the delay in arrival of a package with electronic components, Skarabeusz rover took part only in 1 out of 4 competition tasks and still managed to finish 5th. The new generation of Mars rover, called Ares, contains few iterations, each one responding to the changing competition requirements, technological progress, and increasing experience and knowledge of the team. RS-1 rover was constructed in 2013 and was used by the team to test some new systems and components, such as unique wheels, which you can see on the screen, and which are made of PVC pipe and aluminum angles. RS-1 rover took part in both competitions, European Rover Challenge and University Rover Challenge, finishing in 8th place. And the second iteration of RS Mars rovers, called RS-2, was constructed 1 year later in 2015 and consisted of systems from the first iteration, RS-1, as well as new systems such as new manipulator and new 2-stage suspension, partially derived from the suspension used in railway vehicles, which gives it some specific appearance. RS-2 rover also took part in both competitions, European Rover Challenge and University Rover Challenge. And the last iteration of RS Mars rovers, called RS-3 rover, was constructed 1 year later, 1 year after the RS-2 rover in 2016, and was in fact a modernized version of RS-2 rover with new grippers, electronics, casing, and with new wheels that was specially designed to produce less vibrations than wheels with aluminum angles. In addition to the participation in URC and TRC, RS-3 rover participated in first Polish analog mission to Mars, EXO-17. And now SCA Robotics team is working on the brand new rover that we called Sirius. It is scheduled for the URC 2018 and will be equipped, among others, with autonomous navigation system. And the last rover that I will mention is Gaia Platform. It's a small 30 by 30 centimeter platform that equipped with stereo vision that team use for testing the autonomy system of our rovers, because it's much easier to test the systems on a small rover without leaving the university than to transport a big rover somewhere else to allow it to move freely. Gaia also took part in first Polish analog mission to Mars, which I will talk about. And when you analyze our rovers, you can notice that there are some solutions, some components that don't change with subsequent iterations. And there are also solutions that are being changed in each iteration. And the solutions that stood the test of time are, for example, four-wheeled rover architecture, because it gives a rover a light weight, and when we locate the wheels in a proper way, we ensure that the rover is stable. The next system is a Rover Frame that consists of 2 aluminum pipes and 2 aluminum square profiles welded together. It also gives this frame a light weight, and we can also attach to it many other elements, such as suspension or manipulator. And the rover wheels made of aluminum angles and PVC pipe that we can modify to different types of terrain by modifying aluminum angles, shapes or size, and by drilling a holes of different size in the PVC pipe. And there are also solutions that are being changed in each subsequent iteration because of changing competition requirements, or because of that the project, that the solution doesn't meet requirements of the constructors or competition conditions. And this is, for example, the drilling system, because on different competitions, during different competitions, we have to drill at the different depths or to sample different mass of soil. And the grippers, when we have to manipulate or pick up very different objects. Now I will tell a few words about the participation of our rovers on Polish Mars analog mission EXO-17, which was conducted at the Mars Desert Research Station in Utah in March 2017, with a mission target of developing team composition strategies for long-duration space exploration. A member of SCA Robotics, Michał Kazaniecki, took part in this mission, and he took care of our rovers, Gaia and RS3. On the screen you can see Gaia rover with EXO-17 crew. And it turned out that Gaia, that was equipped with stereo vision, was suitable for reconnaissance of the area. It was easy to transfer because of its small size, and it had a great ability to move around the habitat. But because of its small size, it had also limited ability to move in the terrain, in the difficult terrain. On the other hand, the bigger rover, RS3, was equipped with manipulator that it could pick up some objects or manipulate it, and had better ability to move in the difficult terrain, but because of its big size was quite problematic in transport. And now I would like to show you 3 short movies presenting our rover, RS3 rover, operating at the Mars Desert Research Station area. And here you can see RS3 rover that picks up a rock. It takes some time because it's not easy to control such as manipulator. And here you can see how controlling RS rover looks like. And how our RS rover is moving. Thank you. And after this mission, some conclusions and suggestions were made, which I think the most important is that it's really worth to have different types of rovers for different applications, because a smaller rover can make a reconnaissance of the area and can also travel between habitat stations with some objects on it. And the second conclusion is that controlling Mars rover in a spacesuit is different than without it, because when you put on the gloves, a regular keyboard or gamepad is not the best solution. And during this mission, a traditional joystick, which you've seen on the movies, proved to be accurate and comfortable. And the last, it's difficult to repair rovers during the expedition, so it is really worth taking care to prepare a reliable construction that won't break up during the mission. And the last part of my presentation, I will now briefly describe some problems and difficulties that me and the whole team experienced during working with rovers from different areas. The first issue is determining the dimensions of the rover. It's really worth to take into consideration these two main factors, which is meeting competition requirements, because it's possible that you are not allowed to construct a rover that size is bigger or smaller than some specific size, and to provide easy transport of the rover, for example, from the place where you store it to the car. So to do that, you have to make a detailed analysis of the competition rules and measure the size of lifts, doors, etc. in the place where the rover is stored, but don't forget about ensuring platform stability. The second problem is about shipment of the rover to the competition site, because the rover package may not arrive despite confirmation from the courier company, or delivery process may take several days longer. These are rare examples that we experienced during traveling to the competition area, and I'm afraid there's a little we can do about it, but we can still try to make a careful selection of courier company and ship the rover well in advance. And when you operate at the hilly terrain, such as Mars Desert Research Station area, there might be some problems with loss of connection when the rover is behind the hill. To prevent such a situation, you can use more power, use repeaters, or plan the rover route accordingly. The next problem could be a high temperature at the competition site. I'm referring here to the University Rover Challenge, where it's really hot, especially when you are exposed to the sunlight. And then electronics and other subsystems may stop working. To prevent this, we can try not to expose the rover to the sun unnecessarily. We can protect sensitive parts from the sun, for example, by covering it by something. And finally, using fans or other cooling systems, such as teammate with umbrella. This problem I encountered during designing a drilling device, which fragment you can see on the picture, which consists of a drill inside of the plexiglass pipe. And it turned out that when the plexiglass is rotating together with the drill, good soil penetration properties are obtained, but the collected soil is poorly transported upwards. And vice versa, when the pipe does not rotate with the drill, these properties are reversed. And to solve this problem, you have to just predict analyzed soil properties. And when the ground is soft, you can use the solution with when the pipe does not rotate with the drill. And when the ground is hard, it's better solution to that plexiglass is rotating together with the drill. And the last example is about operating on different types of ground, because it's really hard to design one set of wheels that matches that will drive on the all types of ground. So it's better to design several set of wheels, each one working on the specific type of the ground. And I will skip that because I'm running out of time. Here are the sources I used to make this presentation. And I have to thank the following people for providing the necessary materials or helping creating this presentation, or both. This is Michał Kazanicki and the entire SO17 crew: Mikołaj Owczarzak, Małgorzata Łazuka, Edyta Żak, Tomasz Miś, and all designers and constructors of Mars rovers in Student Space Association. And last but not least, I have to thank all of you for your presence and attention. Thank you.
I have a question. Your rover with the gripper arm that was picking up the rock, were you using a video camera to see the position to pick up the rock?
During the competition,
Yes.
Of course, we use cameras, but I'm not sure whether on this movie there was camera or just the operator could see this rock.
Okay, let's see if anybody else has questions.
I have a question. I am member of Mars Society Polska from Poland, and I would like to say that we are proud of our students from Warsaw, from students astronautical club, science club, because students built the first satellite, Polish satellite, and launched this satellite 2012. Main goal was to test the orbiting of satellite, and this testing failed. And I know that the student club built the next Polish satellite, PW-SAT-2, and I would like to ask when will be launched, with which rocket, and what is main goal? Thank you.
Okay. So PW-SAT-2 satellite will be launched at the end of this year, or at the beginning of the 2019, with a Falcon 9 rocket. And the main aim is to test some deorbiting system, another sail, yes. That's all.
Any other questions? Was the robot and trolley
remotely controlled from the joystick and the other input devices you used, or did you attempt to use any level of autonomy?
Could you repeat?
Did you try to use some autonomous software to control the robot, or was it entirely controlled by an operator?
Not yet. The autonomous system is being developed for Cirrus rover, which will be ready for URC 2018 competition.
What are your ideas for the architecture of the autonomy for the Sirius robot?
Architecture.
What are your ideas on how to do the autonomy?
Well, it's a quite complicated system. Probably we have to deal with neural networks or something. It's hard to explain now, really.
Top secret. All right. Excellent. Thank you, Michael.
Thank you.